Hello everybody, getting ready to do lesson chapter 5, review and summary for pre-calculus math today. And today we have 0 points here of your goes into your notebook. Hooray! And then we got 70 points here. Will go on your classwork sheet, so have your classwork sheets out. If you don't have any classwork sheets, email me. And we go into our bell work today. Teachers, students, here's today's bell work. Use the sum of the product formulas to write the sum or difference as a product. So write each one of these as a product, students. Give your students about 5-6 minutes for that. Okay, welcome back for the solutions for today's bell work. Sum the product formulas. You should have your formula sheet out so that you can write these into products here, these sums. So for the first one here, 123, that one will become 2 cosine 9 theta over 2 cosine theta over 2 by using your sum to product formula. And then for 124, you should get 2 cosine 5 theta over 2 cosine theta over 2. So by going from your formula sheet, you should be able to derive this going from this to this. Our lesson today, our example 1 for 5.1, recognize and write the fundamental trigonometric identities. So this is on your classwork sheet, students, so copy this down. Reciprocal identities, here they are, your reciprocal identities, and then here's your quotient identities. So fill these in on your classwork sheets. Teachers, make sure they fill this in. And then our Pythagorean identities are here. Make sure you copy those down. You should have these memorized, students. And then your cofunction identities are here. So you should have those. You should be familiar with them, if not memorized. And then we go into our even-odd identities. So you go into your even-odd functions here. And you should have these, you should be familiar, if not memorized here for that. Page 3 of your classwork. And then we go into a situation here. Name the trigonometric function that is equivalent to the expression here and then here. 1 minus cosine squared x, and then secant of negative x. So name the trigonometric function that is equivalent to the expression. And then for this one here, it'd be the absolute value of sine x for 1 minus cosine squared x, taking the radical here for that. And then down here, secant of negative x would be secant x for that one. Okay, moving into our 5.2 to review that. Verify trigonometric identities. So guidelines for verifying trigonometric identities. 1, work with one side of the equation at a time. 2, look to factor an expression, odd fractions, or rather not odd, but add fractions. Look to factor an expression, add fractions, square a binomial, or create a monomial denominator. And then 3, look to use the fundamental identities. Note which functions are in the final expression you want. Sines and cosines pair up well, as do secants and tangents, and cosecants and cotangents. So there is a strategy here to verify trig identities. And then 4, when the preceding guidelines do not help, try converting all terms to sines and cosines. And 5, always try something, just don't stare at it. I mean, break it down, deconstruct it. Let's try this here now. Verify the identity for 33 and 36. So for this here, you have the radical 1 minus sine theta over 1 plus sine theta equals 1 minus sine theta over absolute value cosine theta. So for this one here, 1 minus sine theta, so we need to rationalize your denominator. And to do that, we're going to use a 1 minus sine theta over 1 minus sine theta multiplier for this side over here. And then when we do that, we have 1 minus sine theta squared over cosine squared theta. This becomes cosine, the absolute value of cosine theta. This will become the absolute value 1 minus sine theta. And then you can just take away your absolute value bar, and you have 1 minus sine theta over cosine theta. Note, we can drop the absolute value on one since it is always non-negative. So that's our justification for doing that over here. And then 36, this becomes 1 plus secant x, because these are equal expressions here, minus sine x. This is equal to minus sine x minus tan x. 1 plus secant x over negative of sine x. 1 plus, this will become 1 plus secant x. And then when we break that down, it'll break this down. It'll become 1 over sine x equals the negative of cosecant x. We go from here to here. 1 plus cosecant x, that will be, these will cancel, then this will be 1 over the negative of 1 over sine x. Okay, into 5.3. Solve trigonometric equations involving multiple angles. To solve equations that contain forms such as Ku or cosine Ku, sine Ku, or cosine Ku, first solve the equation for Ku, then divide your result by K. So that sounds like a good strategy. Use inverse trigonometric functions to solve trigonometric equations. After factoring an equation and setting the factors equal to 0, you may get an equation such as tan x minus 3 equals 0. In this case, use inverse trigonometric functions to solve. So let's try one of those. Find all solutions of the multiple angle equation in the interval 0 to 2 pi, and we have cosine 4x multiplied by cosine x minus 1 equals 0. So cosine 4x equals 0. We can break this down. And then cosine x minus 1 will equal 0 in this interval here. Then we have 4x to equal 0. We'll have all these values where 4x will equal 0. Cosine 4x equals 0. And see, or cosine x equals 1. So you would have all these values here for cosine 4x. And then cosine x equals 1. We're going to solve this for 0, so we get cosine x equals 1. And then here's your values for that function that will equal 1 as well. So you can also verify this by using a graphing calculator. And then use inverse functions where necessary to find all solutions of the equation in interval 0 to pi for this expression here. So we need to break that down. Tan x plus 4, tan x minus 3 equals 0 when we break this quadratic down. 5.4. Use sum and difference formulas to evaluate trigonometric functions. Verify trigonometric identities and solve trigonometric equations. So, sum and difference formulas. Sine u plus v will equal sine u cosine v plus cosine u sine v. And then sine u minus v, these are our sum and difference formulas, will equal sine u cosine v minus cosine u sine v. And then cosine u plus v will equal cosine u cosine v minus sine u sine v. And then cosine u minus v will equal cosine u cosine v plus sine u sine v. So here are your sum and difference formulas here. So going more sum and difference formulas, tan u plus v will equal tan u plus tan v over 1 minus tan u tan v. And then tan u minus v will equal tan u minus tan v over 1 plus tan u tan v. So this is a long list here of those sum and difference formulas. Find the exact value of the trig function given that sine u equals 4 over 3 and cosine v equals negative 7 over 25. Both u and v are in quadrant 2, so that'll help us there with our values. And then we have tan u minus v, and then down here we have sine u minus v. So find the exact value of a trig function. So to get to that, tan u minus tan v, this equals this here, sum and difference formula. 1 plus tan u plus tan v. And then when we break this down further, because we have these values up here, 4 over 5, it'll give us our triangle that will be relevant to these values. The negative of 4 over 3 minus 24 over 7. That'll be in the numerator over 1 plus negative 4 over 3 multiplying by negative 24 over 7. And then when we crank this out, we'll get 44 over 21 over 39 over 7. That's what this becomes. And then when you simplify that, you'll get 44 over 117 for this here with these stipulations up here. And then down here, sine u minus v. This will become sine u cosine v minus cosine u sine v using our sum and difference. And then furthering that one, and when you plug in our values now from our quadrant 2, 4 over 5 multiplying by negative 7 25ths minus negative 3 over 5 multiplying by 24 over 25, and then this cranks out to 44 over 125 for the second, the independent practice on that. Okay, then we go into 5.5. Use product to sum formulas and sum to product formulas to rewrite and evaluate trig functions. So here are our product to sums. So we go from our products over here to our sums for these different elaborations of our sine and cosine. We have our 1/2 out in front, and then our different iterations depending upon the order of our product here. And then we continue that, sum the product formulas here. So we have our different sums over here, and then we come up with these different products over here. These should be at least known, if not on a list, and so you should be familiar with these after doing 5.5. Let's try one now. Use the product to sum formulas to rewrite the product as a sum or difference. So we have this product here, and then we have this sum here. So we're going to go into a sum, and this will go back into a product. For this one here, so we're going to take this 6 out, then we have 1/2 sine pi over 4 plus pi over 4 plus sine pi over 4 plus pi over 4. And then this will become 3 down here, and then these will reduce into sine of pi over 2 plus sine 0 will equal 3. Because this is 1 here, 3 down to 1 will equal 3. This will be 0, because this will be pi over, see pi over 4 to be 2 pi, see sine of, see that would be 1/2, see plus 0 here. What are we getting here? See 1/2 of sine pi over 4, pi over 4, plus sine pi over 4, pi over 4. And then that will become 3 times sine pi over 2 plus sine 0. Oh, I see. Okay, so it'll be sine 1 plus sine 0. That will equal 3 here. And then down here, cosine 5 theta plus cosine 4 theta. And then this will become, when we use our 1/2 here, or rather, this will be our 2 cosine theta. Again, using our sum the product formulas, this will be 2 cosine multiplying by 9 theta over 2 multiplying by cosine theta over 2. And that is your 5.5, chapter 5, review and summary, part 1 of your classwork. Email me here for solution PowerPoints on your homework, or down here for other course materials. Thank you very much.